Welcome back, folks. We're still looking at this same very simple BJT circuit. We figured out how to confirm that it's in the active region. We figured out how to make two different changes that push it into saturation. Now I want to go through some changes that will move it to the cutoff region. And the cutoff region, we can get there again in two different ways. Okay, so here's the original circuit again. And there it is. Okay, so we want to play kind of the same game, but do it the opposite way. If we put this into cutoff, it's going to be an open circuit. Okay, and if this is an open circuit, we want no current flowing through here, which means no voltage drop. And if there's no voltage drop across here, here's 5 volts. We don't change. We want VC to also be 5 volts. Okay. So we want it to be about 5 volts. It's going to, in some cases, it's going to be close, but not perfect. All right. So we have to consider what changes we can make to make that happen. So if we want no current to flow through here, one thing we can do is cut off the flow of current through the base. And we can do that by increasing this resistance. Okay, so we swap out the 86K. What value did, 100 meg. Look at that. All right, well, let's put 100 mega ohms in there. So that's pretty stinking big. And where's that going? That's down here, right? 86K became 100 meg. And then we go do the analysis. So let's grab some MATLAB for that. And let's make sure that hopefully that was right when I ran it before. Yeah, it was. Okay. Let's make sure we make the correct changes this time. All right, save that. This one's going to be 7. Okay, so let's see, this is still 150. And now this becomes 100 meg, which is going to be 100, and mega ohms is E6. And we run that. Let's see what comes out of that. Okay, we get 4.99. Oh, you're not, well, I'm sorry, I didn't zoom out. 4.9987. So we're going to call that pretty stinking close to 5. Okay, so maybe we can say it's not quite equal, but we can say, yeah, it's essentially 5. Okay. And we can check this. And here comes the ambiguity, folks. We can say, well, what is VBE? Well, we can say that's 0.7, which we would interpret as forward. Okay, we got to be a little careful with that one because that was one of our assumptions, right? We assumed it was 0.7, so that's why it's 0.7. Well, what if it's not actually 0.7? We don't necessarily find that from this, and this is where this table runs into some trouble. Okay, so let's look at VBC, and we see, well, that's 0.7 minus 5. Right, so that's going to be negative 4.3. Okay, volts, which we would typically look at that and we'd say, hey, that's reversed. Reverse biased. All right, so we come over here and we say, okay, BE is forward and BC is reversed. We might think that's active. Okay, but the problem is we're checking our assumption based on our assumption. Okay, so I need red for this. Don't do this. Okay, don't check your assumption by using your assumption. It's just it's going to go poorly for you at some point in life. Don't check assumption by using assumption. Okay, and this is one of the other reasons why I really prefer to just look at the voltage across CE by using assumption. Okay, so let's do it the other way, and let's see what happens. VCE, well, E is still grounded, so it's going to be 5 minus 0 is equal to 5 volts, right? And if we open this up, and I think we did this in a previous video, and we found the open circuit voltage across VCE, we found that it was 5 volts. Okay, and because of that, we can say, hey, this is in cutoff, and we would be right. Okay, what's going on with that BE junction is we've increased this resistance so much, right, that the diode is no longer forward biased. We would really have to look at the current to find this out. We have our diode VI characteristic here. So this is the voltage, this is the current through the diode. Let's actually call it BE and VBE, and you know, we have our curve that looks something like this, and out here is 0.7, right? 0.7 volts, but we're not allowing that enough current to flow, right? So we're never going to hit that 0.7 if we don't allow current to flow. So in reality, we're going to be down here, okay? And that's going to be our actual VBE through there, and the reverse bias region starts over here, right? So reverse biased. Okay, we're actually in the reverse bias region, even though it looked like 0.7, we never quite got to 0.7, so that resistor, that diode, that PN junction didn't turn on. So it's really reversed, and if they are both reversed, we see that they're in cutoff. Okay, so the table's correct, but how we check the table, we gotta put a little thought into it when that BE junction is actually reversed. Okay, I checked this both ways. I want to make another change. I want you to think about the other change that we can make to push this into cutoff. If I leave RB at 86K, what can I do to push this into cutoff? And I'm probably going to make a change over here to RC. So think about that before you keep clicking through the videos. I know these are thrilling. Stay tuned and good luck, folks.